Alright, in this example we have two unknown unit vectors, a and b. We know that the cross product has components 1/4, negative 1/4, 0. We want to find the possible value in degrees for the angle theta formed by vectors a and b, and theta is going to be between 0 and 180 degrees. So we've got the nice formula that the magnitude of a cross b, that equals the magnitude of a times the magnitude of b times sine theta. So again, this is going to help relate it's going to help us relate the angle between those original vectors. Well, a cross b, we can compute that by just taking the magnitude, or finding the magnitude. So we'll square the components, 1/4 squared plus negative 1/4 squared, and then we would have 0 squared. Alright, well, again, by assumption, a and b are unit vectors, and if they're unit vectors, they both have length of 1, so that'll make that easy for us. Well, let's see, underneath the square root, we would have 1/16 plus 1/16 plus 0. That's going to equal sine of theta. Well, that's going to give us the square root of 2/16 equals sine theta. And we can always simplify this a little bit more. We can make this the square root of 2 over the square root of 16, which would be 4. And I'm going to simplify this a little bit, so just to evaluate it. This is definitely, I don't know an angle off the top of my head. Sine of what angle gives me root 2/4. So let's see, the square root of 2 divided by 4. I'm getting this to be roughly 0.35, and I don't know, we can round it one more, 0.0354. So now I'm just going to use the inverse sign of both sides to solve. So we'll get theta equals arc sine of 0.354. So let me plug this into a calculator real quick. So arc sine of 0.354, make sure everything is in degrees. I'm getting theta to be roughly equal to 20.7, we'll just say 20.7 degrees. So that's one of our possible solutions. Recall though, if we're looking at angles between 0 and 180 degrees, so now I'm kind of thinking about unit circle stuff. So if we're looking for angles between 0 and 180 degrees, we found one of the solutions to be 20.7 degrees. There would be another solution in the second quadrant, and to get that one, we'll just take 180 degrees, and we'll subtract away 20.7 degrees. So let's see, I guess if we subtract 20, that would give us 160. If we subtract another 0.7, that should leave us with 159.3 degrees. So those would be approximately our two possible angles, 20.7 degrees and then 159.3 degrees.